Okay, hi, welcome to this tutorial where I'm going to show you how to draw a compressed air water rocket in SolidWorks. And the key with SolidWorks is there's hundreds of ways of drawing something, and what I'm hopefully going to do is show you one of the easiest ways of doing it. So just kind of so you make the workflow as simple as possible, and you get to where you want with the minimum amount of effort. That said, the first thing if I'm going to draw something in SolidWorks is, has someone else drawn it already and can I use it? So actually I quickly checked on GrabCAD to see if there was a bottle available, and also found for an egg as well. As it happens, the ones available online are too inflexible to use, so we're going to design our own. Same with the egg, I found it was the right shape but it was the wrong size, so actually we're going to draw the bottle and the egg ourselves because that's what we need to do. Okay, so I'm also going to try and exercise good practice in doing SolidWorks parts and assemblies, so that you get used to the idea of how you sort of manage these projects in a professional way, so that you don't lose stuff and you don't delete stuff, and it's done in an organised way. Okay, so I'm using SolidWorks 2020. It should be pretty similar whatever version of SolidWorks you're going to use. So the first thing we're going to do is draw the bottle. So we're going to click on a new document, and it's going to be a new part. Okay, SolidWorks opens up as a new part for ourselves, and the very first thing I'm going to do is save it. So we haven't done anything, but I'm going to save it because that means I'm not going to get into a mess where I can't find it or it's in the wrong place or whatever. So I always encourage you to, as soon as you start working on a part, to save it. SolidWorks. And in that, I'm going to call my part bottle. It's going to save it as a part document. Okay, there we go. It says it saved it. It's called bottle. And we're going to draw it on the front plane. So facing forwards, that's where our profile is going to be. So do new sketch. And because this bottle is going to be something that we're going to revolve, we need an axis of revolution. So actually the first thing I'm going to do is just draw an axis. A center line, and does it straight for me, and you've drawn that, and when you finish your line, if you just pull away and then double click, it just leaves the line you've done, and that's our center line. And what I'm going to do is actually keep that as a separate sketch, and then it's there and I can use it for other things if I need to. So let's now have a go at drawing the bottle. So we're on the front plane again. And as ever with SolidWorks, the first part is just getting some geometry on, and the second part is putting the dimensions on. So we're going to simplify this bottle. So it's going to have a neck to it, and it's going to have some parallel sides, and then it's going to have some curves that join the top to the side, and then the neck to the sides. So it doesn't really matter in what order you do it in, but probably the most sensible thing to do is draw the straight things first. So I'm going to draw some sides. So that little yellow bar tells me it's straight, so that's good. Click there, go into space, double click, and that leaves the line. I've got the neck of the bottle, and I'm going to put that level with the origin, and I'm going to draw a little straight line going up. Move away, double click, it leaves the line. And then I want to join these things up to make the curves on the bottle. And having practiced this just a bit earlier, when you're making shells, one of the things you have to be careful of is that SolidWorks won't do a revolved shell if the surface actually touches the axis of revolution. So when I connect these up, I can connect these up, but when I connect this up, I'm just going to leave a little gap there, and then SolidWorks won't throw wobbly, and it will do a shell for me. Okay, so those lines are good. If we now add some splines, so the wiggly one there is a spline, and we can just connect those two together, and you collect that one up and you click it, and then you have to double click again, and then that just leaves a straight one in there, but these handles have appeared. If you do it wrong or do it differently, you sometimes end up in a situation you connect it, and if you move it away you get this kind of wobbly thing like that, and then if you double click it you'll end with that. So you don't want that. You want to join the dots up. When you arrive, click on it and then double click to finish. And then this top one, as I said, we're going to move it across, but we're not going to go exactly on. We're going to get close, but not actually touching. Okay, so we've got our line in there. Once again, I'm going to show you what happens if you do it wrong so you can fix it. So imagine you're putting this in and you connected it up, and that little yellow thing appears to tell you it's attached. Put it in, and if you've done that, what you find is now that is attached to this line, or it's got a relation, so a coincident relationship. And if you do this, you can't do the revolve easily. So if you do this, what you can do is just go up there, and if you click on that little icon, and you can click delete, and then it's gone. And when it's gone, you can just pull your line slightly off the edge there. Okay, so a lot of these little things you have to get used to doing in SolidWorks to get it to do what you want. What I'm going to show you here is some top tips for dealing with splines, making them do what you want them to do. So these things here are called the spline handles, and you can vary the angle of them, and you can vary the kind of weight of them and how much they pull. And you can use this to make the shape of your bottle. The key thing about the bottle geometry is that actually this is a tangent here, this curve. So this thing has to be straight up, so it's no good doing it like that. That's not realistic. So what we can do is set a constraint on it. So if we make that handle vertical, and if we make that handle horizontal, we can now just control the weight of them, but we get a kind of a sensible design for our shape. Okay, that's the ones at the top. And if we do the ones at the bottom, same again, I'm going to make this one vertical, and actually this one I'm going to make vertical as well, and that'll give us a nice blend into the bottle. That thing's pulled up, so what I'm going to do is make it level with the bottom there, and we're going to change these dimensions in a bit, but just get it about right. Okay, so it's going to be something like that for our bottle. Okay, that's good, so tick off that. Now let's put some dimensions in. So the first crucial dimension is the dimension of the neck there, and the inner diameter of these bottles is 22 millimeters. So 11 millimeters radius, and so what we're going to do is we're actually, when we make the shell, we're going to make it go outwards. So I'm going to set this to 11 millimeters, and that'll correctly make the inside of our bottle. Okay, so I've got a 2 litre bottle in front of me, and it's about 320 millimeters high. So you can just measure these off with a ruler. So that's scaled it up like that, so it's gone a bit wonky. We can pull that up. No, we can't, because I'm still doing dimensions. We can pull that up like that, and the diameter of the bottle is about 120 millimeters, so 60 millimeters radius. Okay, starting to look a little bit like a bottle. The other thing we need to sort out is the length here, and the neck on my bottle is about 25 millimeters. The other bits are, you can sit there with a ruler and work it out. There's a little bit of artistry just to fixing it, but you can vary the shape like that. And one thing I have just noticed is, because I didn't fix this in place, it's moving. So I need to sort that out. I'm going to drag that over there, and I'm going to put a dimension between there and there, and just tell SolidWorks it's 1 millimeter. Okay, and that stops it moving around. And one thing you'll notice is that as you fix things, they go black, and when they're blue, that means they can still move around. Generally, a drawing isn't finished till everything's gone black. In this case, because we've got some splines, we're not defining things completely at this stage. Okay, I think that'll do. That looks a bit like a bottle. Great, so we've got ourselves an outline, and what we now need to do is make a solid out of it by rotating it. And I've just spotted another issue. So this is good to show mistakes, but this dimension's gone wonky, and the reason it's gone wonky is I didn't enforce this being horizontal. So if I want to enforce that being horizontal, if I click on both of those, select them both, and then force them to be horizontal, it shimmies it up and makes it straight. So another quick check. Have I made any other mistakes? Seems to be okay. So let's have a go at rotating it. We're going to do that as a revolved boss base. It tells me that the sketch is currently open and a non-thin revolution requires a closed sketch. We actually want a thin revolution, so we can click no to that. First thing it does is it asks me for the axis of revolution, and that's what we drew first. So it's this little guy down here. If we click on that, and bingo, it did it straight away. So SolidWorks is incredibly stupid sometimes, but incredibly smart other times. It's done a 1 millimeter, 10 millimeter wall thickness. Actually, our bottle is closer to 1. So, in fact, it's actually even thinner than that. Let's do it as 0.5. And there we go. It's made ourselves a bottle. So that's pretty cool, isn't it? So we did a few lines, a revolve, and it's turned itself into a bottle. It would be nice if we could see through this, because that's more like what a real bottle's like. So let's change the material properties on it, or the appearance rather, and we're going to apply it to the whole bottle rather than in a particular surface. And the key trick here is you've got to click on advanced and then illumination, and then there you can get to transparency. So we can change the transparency amount. Let's put it up to 80%, and I'm going to make it a little bit luminous as well, because that kind of makes it look a bit more like plastic. But there we go. We've now got some sort of plastic bottle, and the way it's rendering it is doing lines and surfaces. If you just wanted to see what it looked like without any lines on, you get that, and there's your bottle. Okay, you wouldn't win any art prizes for it, but it's a good start. Okay, so we've got a bottle. Let's save that. And what should we do next? Okay, let's make some fins. So I am going to start a new document. Part. Okay. And I'm going to select the front plane, and I'm going to draw a fin. So make it straight there. That yellow line's told me it's straight. It doesn't really matter how you do these. I'm going to join it up to there. When you've made a closed shape, SolidWorks goes grey. So if you don't close it up properly, it won't go grey. And sometimes when you can't extrude things, you end up shouting at SolidWorks. But what it is you haven't closed the path, so it can't extrude it. Okay, let's extrude that now. And it's made a pretty good guess, but our fins are going to be made out of 3 millimeter foam, so let's make it 3 millimeters. And what I'm going to do, just because we want this thing to be precise, what we're going to do is we're going to do it from the sketch plane, but we're actually going to do it mid-plane. So if you notice, when I selected that, the extrusion now is about the middle of the plane. And what that means is when we stick this fin onto the rocket, that fin is in the middle. So if we make that to a flat surface or make that to a plane, the fin's going to be in the middle. If you don't, all your fins will be offset slightly. Little details like this, you probably wouldn't notice it, but actually if you're constructing a rocket and you didn't do this, all your fins would be slightly in the wrong place. Okay, and I broke my rule of not saving it as soon as we started, but anyway, I'm saving it now. Call it fin, and there's our foam fin. Let's leave it grey because Depron's grey. Great. What should we do next? Let's draw an egg. So, new part. So the egg is a little bit like the bottle. We're going to do it as an axis of revolution, but this time it's going to be solid, so it's slightly easier. Do front plane. I'm going to do my little axis to start off with, just because we might need that again in a bit. So that's our axis, and do another sketch which is on the front plane, new sketch, and then we're going to draw our egg. So this time we just need one spline. We're going to start there, and we're going to end up here, and I'm actually going to fix it to that line, and it's there. And then we can start messing around with the egg again. So what shall I do? Let's put the dimensions in first. So I just looked this up on Google. So a typical hen's egg is about 60 millimeters high. Okay, and then I'm going to do the same trick with these handles. So a realistic egg is going to be, the curvature is going to be smooth at the top and bottom. So those are relations. So now we can shape our egg. It's kind of egg shaped. Yeah, that'll do. Just want to check that this line and this line. Okay, so that's telling me if I look on that constraint there, it's coincident. So that line is coincident with that one. So that's good. We know it's on the center line. Do our revolved boss base. The sketch is currently open. Okay, this time we do want to close it because our egg is going to be solid. And same again, axis. If it's asking for the axis revolution, click on the axis. Bingo, we've got ourselves an egg. Slightly funny shape, but that'll do. Always change it later. Okay, let's make our egg a nice colour. So appearance, part, and let's just make it brown. Okay, so it's annoying me slightly that it's not quite like an egg shape. So I'm going to go back to the sketch, edit the sketch again, view it head on. Why doesn't that look like an egg? Let's do these guys. I reckon I made it too bulgy. That's more like an egg. Oh, there we go, perfect. Okay, so we've made an egg, and I'm just going to hide that sketch because we don't want to see that. Great, and save it as egg. Great, so let's put something together now. So we're going to do new. This time we're going to do assembly. And it's going to start in a new assembly file. So remember, you make parts and then you put them together in an assembly file. And it's immediately found some things to put in. And what I'm going to do is click this little pin here, and this means this dialog box doesn't go away. I'm going to put the bottle in. And if I drag it over, I can sort of put it anywhere, but if I just hit return, it sticks it at the origin. And that's useful because okay, good old SolidWorks. I had to hit return twice and now it's stuck it at the origin, but there we go, so it's fixed in place. That's good. And if we right click to tick that, our bottle's in there. If we want to put the other bits in, if I do insert components again because that disappeared, let's put in a fin, and this time I'm just going to put it somewhere semi-random and then sort out exactly where it's going to go in a second. Okay, so let's align the center of this fin with the front plane, and this is where your skill in doing mates in SolidWorks comes in. So if I take the front plane of the fin, which is what we drew, and then paperclip, so I'm going to mate that to the front plane of the assembly. There we go, slid it in place and tick that. Tick it again. Okay, so that means now that that's the front plane. Let's tick that to get rid of that. So that the front plane of the whole thing is there, and the front plane of the fin is lined up with that. So I can pick this fin up and move it around anywhere and it'll be on the front plane, so that's good. But now what I'd like to do is put some more fins on. So what I could do is just bring in some more and then mate them to the other planes and so on. But because I'm lazy, I think, I'll tell you what, I'm just going to do a repeating pattern. So it's going to be a circular pattern, and I'm going to repeat the fin round. So if I go to patterns, so circular component pattern, it's smart enough to recognize I want to do the fin because I was already on that, and then it's asking for a direction, and this is where you see why we left that sketch in, so we can use that as our direction. And we're going to put 4 on, and let's do them at 90 degrees, and then the magic button to create more fins, 4 fins. Okay, and then we're good. So it's starting to look a little bit like a rocket. So if we get our original fin, it'll tell us which one it is. If we move that one, all the fins will move, so we can move them in and out and so on. So if we just let's view it from the front, and if we get this one in the right place, then all the others will go in the right place. At this point you'll realise that actually making the fin flat means we can only stick it on here, and actually the smart money for fins, if you've done your simulation work, you want the fins as far back as possible to make them as effective as you can for a given size. So you can immediately see actually if you're going to start designing your fins, you probably want them stuck on there, in which case you're going to have to change the shape of the fins. And what I'll do is I'll just quickly show, assuming I'll keep them flat for now, but I'll show you quickly how you might edit in place the shape of the fins. So here we are, we want to change the shape of our fin, and if we click on it, these options come up, and this one here is edit sketch, and what that's going to do is edit the sketch of the fin. So this is called in place editing. Assembly must be saved. Ooh, okay, I forgot to save the assembly. Okay, my bad. So I broke my own rules again. So rocket assembly saved as assembly. Okay, thank you SolidWorks. Have another go, click on that, edit sketch. Okay, and we can now see our little fin come up, and say maybe we wanted the fin a little bit bigger, we could stretch it out that way. Okay, it's trying to fix it to there. Okay, I don't want that, so let's ignore that. I think what happened there was it tried to mate it towards the bottle, so okay, that didn't quite work as intended, but anyway, let's do that. Interesting. Okay, that's fixed as vertical, so I can only move it up and down. So that little yellow thing, it's going to throw a little wobbly every time I do that. If you press Control when you're dragging something, it doesn't try and constrain it. So when I press Control, that little constraint moves away. If you do get an unwanted constraint in there, you can always get rid of it afterwards by deleting it, but that's just one of SolidWorks trying to be over helpful. Okay, so we've changed the design of the fins a little bit. Press Return. We're still in fin editing mode. As you can see here, we're still editing the part, and so this fin hasn't changed, but if I now exit the part, all of the fins have changed. Okay, it wasn't too dramatic actually, but you can see there, you just edit one part and they all change. Okay, that's good. Let's put our egg in. So insert component, egg, and stick it roughly in the right place. So with these round things, it's always a bit more tricky constraining them. So what we really want to do is just force the egg to be on the center line, and then we can move it up and down. And the way I'm going to do that is by mate its front panel of the egg to the front plane of the rocket, and I'm going to do the right plane of the egg on the right plane of the rocket assembly. Okay, so now I've constrained it. The egg can move up and down, but it doesn't move sideways. So that's good. So for design, we can vary the position of the egg this way, but it's not rolling around all over the place. Okay, so that's looking quite good. Next up, we need some sort of nose cone. So what we could do is just redraw something from scratch. We could make a sort of a bit of a bottle shape and use that from scratch to make a nose cone. But again, being lazy, we're thinking, hang on a second, we've drawn a bottle, why don't we just reuse that, change the shape slightly and use that as our nose cone. So that's what we're going to do. So we're going to go back to the, I'll save that assembly, we're going to go back to the bottle. That's our original part, and what I'm going to do is File, Save As, and you have to concentrate quite hard here. But so first off, give it a different name. So let's call it nose cone, and then what we want to do is save as, copy, and open. So if you do that one, it's going to create a new part and open it. And let's do save. And then it comes up with this strange dialog, keep the original document open, blah, blah, active. So we're going to go back to doing the bottle again. So let's just do that one and keep the original one open. So the thing to check when you're doing copying things or a save as is just look up, see which part you're editing. It's very easy to create a copy and then make all the changes, and then you suddenly realize you've been editing the original part. So this is the original bottle thing, but it's saved as a new part called nose cone, and we've opened it up. And what we want to do for the nose cone is just use the top half of this. So what we're going to do is go back to our sketch for that. Look at it face on, and essentially we just want to keep the top half of that. So I'm just going to wade in and start deleting stuff. Okay, that'll do. Let's just leave it at that as a nose cone. You know, you can vary that to whatever length you want. And there we go, we've got a nose cone. That was quick. If the nose cone's got to fit over the top though of the existing bottle, it needs to be slightly bigger actually. So what I should have done is made it slightly bigger. And let's make it 1 millimeter bigger on either side. So make the diameter 61, the radius 61 rather than 60. So that made it slightly bigger. There we go, we've got a slightly bigger nose cone. Save that. Go back to the rocket assembly. Insert component. Nose cone has appeared here. If it hasn't, you have to go and kind of navigate to it. Sometimes it doesn't find it. And let's bring it in. And again, it doesn't really matter where you put it for now, but let's just bring it in. Okay, so we need to align it up, but actually because we've left this axis in, we can use this to our advantage. So if you click on that axis and then do mate, and then if it will find that one, there we go, lovely. Okay, so no messing around, we align the axes, and now our nose cone slides up and down. Having done that, I quite like not to keep looking at that axis, so I'm going to turn that off and include that one. I'm going to hide that so it's gone. There we go, we've got ourselves some sort of rocket. So you could choose where you wanted the nose cone to go. You've got to get a parachute in there, you've got to get some string attachments, you've got to have some sort of protection for the egg to go in there. And the other thing which you might want to have a look at is the kind of geometry around the bottom is reasonably important as well. So getting the neck on the bottle right is something you could add in too. So if you wanted to do that, you just draw another little part there and revolve that. Okay, so that's really a quick whiz through how you design a rocket. As you can see, I had a practice go with that earlier. I should know what I'm doing, but I still make loads of mistakes when I'm doing it. So just be gentle on yourself when you're doing it. If things get locked up or it's not working, you know, you get all the triangles everywhere saying it's not broken. It's broken. Sometimes you just have to delete something and start again. And you only get good at SolidWorks by practice. No one is born good at SolidWorks. So be gentle on yourself. Allow yourself to make mistakes. Have a go at it, and if you get stuck, sometimes it's easier just deleting things and starting again. So with this model, the expectation is that each group produces a CAD model. It's a shared learning experience, so everyone should be having a go at doing some CAD. Maybe one person does fins, one person does an egg. I think what you want to avoid is just one person in the group doing SolidWorks, because this is your opportunity to actually learn how to use it properly. You've got somebody to draw a parachute, you've got the egg protection system, you've got string. Drawing string in SolidWorks is quite tricky. So in an ideal group, everyone would be responsible for designing a different part, and then you bring it all together. And then when you come to the build phase in the lab, you show up to the lab with your tablet, phone or computer with the CAD model on, and you spend the time in the lab building things, and you've done all your thinking and designing in SolidWorks. And that's the right way of doing it. So you think about all the geometry and what you want to happen in SolidWorks, where it's nice and flexible, and then the lab time is spent, you know, working out how the hot glue guns work, you know, tying bits of string on and so on, so that you use your time most effectively. Okay, so I hope that was a useful introduction to drawing a rocket, and best of luck when you're creating your own.